Let's work on implicit differentiation, and for our first function, let's differentiate 2y equals x squared plus sine y. Let's go ahead and take the derivative of each term, d dx of 2y equal to d dx of x squared d dx of sine y. So the derivative of 2y with respect to x would be a power rule, which is just 2, but this time we'll use dy dx because we're differentiating in terms of x. The second term, we don't have a problem with that because it's just simply 2x, and we don't need to put a dy dx or dx over dx for this one. And for the third term, since we are working with a function of y, we'll use the implicit differentiation again. The derivative of sine y is cosine y, so we have cosine y times the derivative of the inside, which is y. So using the chain rule, we'll simplify this in a little while. So here we have 2 dy dx equal to 2x plus cosine y dy dx. So what we're going to do now is we're going to group the dy dx together, and then the 2x will be left right here. So by subtracting cosine y dy dx on both sides, we'll end up with 2 dy dx minus cosine y dy dx equal to 2x. And since we need to isolate dy dx in our equation, what we can do is factor out the dy dx, and we'll end up with 2 minus cosine y dy dx equal to 2x. And by dividing both sides by 2, cosine y, 2 minus cosine y right here. This cancels out, and dy dx is equal to 2x all over 2 minus cosine y. And most of the times we also use y prime to denote the derivative of the function. So this is now our derivative using implicit differentiation. Now let's go ahead and work on the second example. So we have e to the xy plus x squared minus y squared. So we need to know the derivative rule for e to the u, which is e to the u du dx, and just power rule and the constant rule for the other terms. So we'll end up with e to the u du dx. So we'll copy e to the xy and take the derivative of xy. And we'll do that later on because we're going to be using the product rule for this function. Plus derivative of x squared is 2x minus, this time we'll have 2y dy dx equal to 0. So by using the product rule, let's copy e to the xy and take the derivative of xy with respect to x, and we will end up with, usually I just take the derivative of the first and copy the second, plus copy first derivative of the second, which is dy dx. And that's my product rule for xy. And the rest of the function will have negative So by simplifying this, I will distribute e to the xy to my function here so I can isolate later on dy dx in my equation. So I will end up with y times e to the xy plus x e to the xy dy dx plus 2x minus 2y dy dx to 0. So I know that I can group this together, and I will transpose these two terms right here on the other side by the additive inverse, so minus these terms. So I'll have, now let's go ahead and get rid of these two terms right here by using the additive inverse, and the dy dx will stay on this side of the equation. So we'll end up with x e to the xy dy dx minus 2y dy dx equal to y e to the xy minus 2x. So we did that because we can subtract y e to the xy on both sides, leaving us with negative y e to the xy right here, and subtracting 2x on both sides as well will leave us with negative 2x right here. So now that we have isolated the dy dx, let's just factor out the dy dx here so we can have dy dx by itself. So we have x e to the xy minus 2y dy dx negative y e to the xy minus 2x, and by dividing both sides by this term, x e to the xy minus 2y and x e to the minus 2y. By canceling this, our dy dx will simply be this term right here. So we'll end up with, let's simplify this function right here into dy dx of negative y e to the xy minus 2x x e to the xy minus 2y, which is also y prime in some notation. So this is how we take the implicit differentiation for this particular function. Now for our third example, let's take the derivative of x plus y squared equal to the cube root of xy. So taking the derivative of each term, so notice that I changed my cube root into 1/3, so that I could apply the chain rule later on in taking the derivative of this term. So derivative of x is simply 1 plus the derivative of y squared is 2y dy dx equal to chain rule, so 1/3 xy, and we know that 1/3 minus 1, which is 3 all over 3, is simply negative 2/3. So this is negative 2/3 for our exponent, multiplied by the derivative of xy. And in this case, we'll use the product rule to find the derivative of xy. So let's simplify our function. So we'll have 1 plus 2y. Let's use y prime, so that we'll have a shorter equation right here. 1/3 xy to the negative 2/3 multiplied by the derivative of this term right here. So derivative of first, copy, plus copy, derivative of y, which is dy dx. And this is now my product rule. So what I'm going to do is to distribute this term right here to x dy dx and to my y. So my equation will be changed into distribute this here, so we have y 1/3 xy negative 2 over 3, and distribute this to the other side right here, which is x times 1/3 times xy negative 2/3 times dy dx. Alright, so now that I have separated all my terms, I have 1, 2, 3, 4 terms. I know that I'm going to be grouping this and this on this side of the equation, and my plan is to get rid of 1 right here and put it on the other side of my equation. So my dy dx will be here. So by subtracting this term on both sides, I'll have 2y y prime minus x times 1/3 xy negative 2/3 y prime. Notice that I changed my dy dx to y prime, and then minus 1 over here, so I'll have y times 1/3 xy negative 2/3 minus 1. Now all I need to do is to factor out my y prime, so I will end up with 2y minus this whole term right here, which is x 1/3 xy to the negative 2/3, and this one will have y prime as their common term or common factor, equal to, this one is y 1/3 xy to the negative 2/3 minus 1. So all I need to do is to isolate y prime by dividing it by this term right here. I know it's quite large, but there's nothing else we could do about it, because it's still going to be a huge solution even if it changes into radical. So let's just leave it as fractional exponent. So our y prime is simply y times 1/3 xy to the negative 2/3 minus 1 all over 2y minus x times 1/3 x y to the negative 2/3, which is also our dy dx. And this is how we take the derivative of x plus y squared equal to the cube root of xy using implicit differentiation.